In this video, we're going to be building out a full-stack NFT marketplace on Ethereum with Polygon, Next.js, and Tailwind CSS. We're going to be working with Hardhat for the Solidity development environment. We're going to be working with Ethers for the client library to interact with the chain. And we're going to be working with IPFS for file uploads and file downloads. Now, I think this is a really interesting and important project because it shows how to put all of these things together. So you're not just writing Solidity, you're not just writing smart contracts, you're not just interacting with an application from the front end. You're actually building the entire thing end to end, testing it out. And this way you kind of really get a good grip of how all of this stuff works. There are two other reasons I think this is an important project. First of all, we're going to be working with NFTs. And I think people are really starting to understand the value of NFTs and not only the applications that we're seeing today for digital sale of goods, but also the idea of physical goods, like attaching an NFT to some physical good in the real world. We're starting to see a lot of people having ideas around that and being able to kind of like tokenize things in the world. So that's a really important concept that's starting to really come into fruition. And I think another really interesting part of an important part of this tutorial is working with a Ethereum or an Ethereum scalability solution like Polygon. Now, if you want to write a transaction to Ethereum, you're probably going to pay a couple of dollars. And also that transaction often takes quite a while for it to be processed and to be verified. With scalability solutions like Arbitrum, like Polygon, and there are a few others out there, they offer faster transactions, but also cheaper transactions. So for instance, it wouldn't probably make a lot of sense to build an application where you're trading in assets that are $2 to $10 directly on Ethereum, because the transaction itself might cost more than that. But when you're working on a layer 2 or a sidechain or some scalability solution like Polygon, the transaction is actually going to be less than 1 penny. So this opens the door to a lot of different applications that people are starting to realize. And I think going forward in the future, you're going to see a lot of applications and a lot of demand for these types of solutions, and maybe even for this exact stack that we're working on. So that's my introduction. I hope it kind of gives you a good overview about what we're going to be working with and why we're going to be working with it. And with that being said, let's go ahead and start writing some code. To get started, we'll be in a brand new terminal window with an empty directory, and we're going to go ahead and create our Next.js app. So to do that, we can run npx create next app, and I'll call this NFT marketplace. All right, let's go ahead and change into the new directory. And here we should kind of see the boilerplate code created for us by Next.js, the initialization of our project. So now we want to go ahead and install our dependencies. So we have quite a few dependencies because we're doing a lot. We can use either npm install or we can say yarn add, either way, whatever works for you. I'm going to go ahead and use yarn add, and we're going to start walking through all of these dependencies. So we're going to be installing Ethers. We're going to be installing Hardhat. We're going to be installing some Hardhat dependencies. So one of those is at Nomadic Labs /Hardhat waffle. We're also going to install Ethereum waffle. And these are all part of our Ethereum development or our Solidity and development environment. We're going to install chai for testing. And I think the last Hardhat dependency that we're going to be installing is Hardhat Ethers, so at Nomadic Labs /Hardhat-Ethers. We're going to be installing Web3 modal, and Web3 modal is what we're going to basically be using to allow the user to kind of choose which wallet they want to work with. And in our case, we're going to be using MetaMask. We're going to be installing the Open Zeppelin contracts, because we're going to be inheriting from the ERC 721 contract that they have ready to go that we can kind of just reference instead of having to write all of that ourselves. We're going to be installing the ipfs-http-client, and this is what we're going to be using to interact with IPFS. And then finally, we're going to be installing Axios. So we have a lot of dependencies there. If you don't want to type all these in, I do have a link in the description of this video where you can kind of follow along and maybe copy and paste some of this stuff. All right, so now that our base dependencies are installed, we can now install our last set of dependencies, and these are going to be for Tailwind. Now, Tailwind CSS is the styling library that we're going to be working with, and it offers kind of a pretty simple or fairly simple way to do styling. So the things that we're going to be installing from Tailwind are going to be dev dependencies. So we can say yarn add -d or npm install -D, and we're going to install Tailwind CSS latest, post CSS at latest, and auto prefixer at latest. All right, so now that all of our dependencies are installed, we can now start writing some code. So the first thing that we want to do is we need to initialize some configuration for Tailwind. And you can either create these files from scratch, but the easiest way is actually just to use the npx utility. So they have a Tailwind CSS utility. And we can say init, and then we can pass in the -p flag. And this is going to create two files for us. One is going to be tailwind.config.js, and one is postcss.config.js. Now, we don't really need to make any modifications to those. We're ready to go. The only thing we need to do is actually import the Tailwind classes, the base classes, and also just the base that we're going to need for Tailwind to work. So to do that, we can go ahead and jump in our text editor, and we're going to need to start writing some code anyway in just a moment. So let's go ahead and open the project in our text editor. All right, so we're here. We have our project open. The styling that we're going to be writing, or the update for the styling that we're going to be writing, is going to be located in styles/globals.css. And here we can basically just overwrite everything. And we're going to pass in the @Tailwind base, @Tailwind components, and @Tailwind utilities. And the 3 lines of code here are going to get us set up with all of the different class names that we can now use in our project. And we're kind of ready to go. There's really nothing else that we need to do. We can save this file and we can close it out. So we have our project set up, and we can now start actually writing some code. Now, what we want to do is we want to start writing some Solidity code. Now, we could start writing that here and create a bunch of different files to kind of get all of this configured for a development environment, but we can also use a Solidity development environment, which is what we're going to use, and we can actually initialize that, and it'll go ahead and create all the stuff we need. So the one that we're going to be working with is Hardhat, and all we really need to do is just run npx hardhat, and this will go ahead and get us set up with a Hardhat environment, as well as some basic smart contract to start working with. So I'm going to choose create a sample project. I'm going to keep the project root at the root that we're in. And then I will choose yes for adding a get ignore, even though I think we already had a get ignore. So now I should be able to go ahead and open up back to our text editor. And we see that we have our contracts here. And we also see that we have a hardhat.config.js. So the contracts hold the smart contracts that we're going to be working with. Right now there's an example contract for greeter. I believe it also created scripts/sample script. So we have that. And I believe also test/sample-test.js. So all of these files were created for us by Hardhat. And we're actually going to be interacting with pretty much all of these except for greeter.sol. We're going to be actually deleting that. So our Hardhat, our Solidity development environment is all set up now. We're ready to kind of move on to the next step. So what we want to do here is we want to go ahead and configure Hardhat to work with Polygon. And to do that, we're basically going to need to go ahead and write a little bit of configuration here, expand on the configuration that we have. So I've kind of gone ahead and deleted some of the comments. I don't actually need this here either. It's just kind of showing you if you did want to get the list of accounts, it's just kind of giving you an idea of how you would do that. So we're actually going to use this function in one of our other files, but for here, we're not going to need it. So let me go ahead and just delete that to kind of make this as concise as possible. Now, for us to be working with Polygon, we're going to need to basically either decide, do we want to interact with the public nodes, the public RC endpoints that are kind of out there, or do we want to work with our own private RPC endpoint? It's kind of up to you. So what I'm going to be working with is Infura, but you could actually do this directly from a public endpoint and not have to create any accounts or anything like that. So let's go ahead and check out some of the Polygon docs. So I'm just going to kind of like, well, actually, let me just look up Polygon networks. And this might just take us to their main developer docs. But let's go ahead and go to developer. We're going to click on proof of stake chain. And then we're going to go ahead and look for networks, network details, and click on network. So here we kind of see the details for both the mainnet as well as the Mumbai testnet. And in this tutorial, we're going to be actually deploying to both the testnet as well as the mainnet. So, you know, just keeping that in mind early on, we might want to have a configuration for both Mumbai as well as the mainnet. And if you kind of scroll down, you'll see a lot of information. We're going to be using some of this information to configure our application as well as our MetaMask wallet. We have like the RPC endpoint. We have the chain ID, you have the name of the token itself and things like that. So it kind of gives you an idea here why you might use your own RPC. It says public RPCs may have traffic or rate limits depending on usage. And that basically means like if we're trying to deploy our contract to one of these test nets, it might fail because there's too much action going on. So what we're going to basically be doing, or at least what I'm going to be doing, is I'm going to be using Infura. So Infura is a provider of these different node endpoints. So I can go ahead, create an account. I'm going to go to Ethereum, and I'm just going to go ahead and click Create Project. And I'll call this something like Next NFT Polygon or something like that. And I can go now to here under Settings. I can see I have endpoints here, and I can see that we have a Polygon mainnet as well as a Polygon Mumbai network. And this is my project ID. So basically, we're going to need this endpoint / our project ID, just kind of how it's listed here. So I'm going to go ahead and copy that, and I'm going to go to my editor here. And what we basically want to do is configure the different networks. So to do that, we can say networks. And we're going to basically have our local node that we're going to be working with, so Hardhat. And this is going to be one. The other one is going to be Mumbai. And then the other is going to be mainnet. Okay, so we have these three networks. For the local network, we do need to add a configuration here. We have to say chain ID. And we need to set the chain ID to be 1337. This is kind of like a configuration that is something having to do exactly with Hardhat documentation. So we just need that there for that to work. For Mumbai, we need to go ahead and set the URL. And the URL is basically going to be that. Now you could also store your ID or your project ID somewhere like in a local environment variable or something like that. And you might, instead of like doing it this way, you might read from that environment variable and say something like this. And then you could kind of say project ID. So let's act like we're doing that, just to kind of like show that we're not maybe duplicating this code because I think we're going to be using the same project ID somewhere else. But in a real world project, you probably want to keep like these ideas out of your source code itself. So it might be smart to put in an environment variable. But let's go ahead and say that we want to go ahead and say project ID is equal to that. And then now we can kind of just use that there. And then we also might say for our mainnet, we want to do the same thing. So Polygon mainnet, I'll copy the address. So now we can go to the mainnet configuration. We can set the URL using that new mainnet URL, and we can also use the project ID variable here. And now we have both our Mumbai as well as our mainnet URLs configured. The last thing we need to do is go ahead and define our accounts. And these are going to be the accounts in which we are deploying or from which we are deploying our contracts. Now, when we're working on a local test network, we don't really need to define an account because the Hardhat test environment will automatically inject and use an account for us unless we define one. And there are an array of like 20 different accounts that are created for you in a local network, each one with 10,000 units of Ether, or in our case, we're working with Matic. And you know, they're created for you locally, so you don't really have to worry about it there. But when you're deploying to a real network, you do have to have some type of payment. And typically you're going to be using, you know, the private key from the address that you would like to deploy from. Now, the private key is going to be a very, very secure type of thing that you never want to really get out there. So it's a very secure value that you never want to put in GitHub or really even write to a local file for the most part. Most of the time you want to use environment variables. But in our case, we're going to be using a completely throwaway account, completely throwaway addresses. So I'm not really worried about exposing these here. I want to make sure everyone is able to be successful if they're following along. And sometimes environment variables are a little tricky to work with. So we're going to be creating a .secret file. We're going to be adding that to .getignore, making sure we don't send this to GitHub. But I just want to emphasize, if you're working with real money, with real tokens, you never really want to expose or hard code this value anywhere. So with that being said, where do we get these accounts? So, well, we first of all need to go ahead and install a wallet that we're going to be working with. So in our case, I'm going to go ahead and install a MetaMask wallet in our browser. And using that MetaMask wallet, we're going to have a couple of accounts. So I can go ahead and search for MetaMask extension. And here we should be given a link to go ahead and install this Chrome extension. And this will go ahead and walk us through getting this set up. So I'm going to go ahead and click Create a Wallet. And I will go ahead and reveal this secret phrase because, again, I'm going to be deleting this wallet after this tutorial. I'm never going to be storing any money in it. But now it's going to go ahead and ask us to go ahead and enter in this seed phrase. All right, so we've confirmed our seed phrase and we should be set up. So we now have our wallet. I'm going to go ahead and pin this to my Chrome browser. So now we always have it here. And what we should see is that we have our one account, and we might even create another account if we'd like. You know, we have a couple of accounts that we can work with. We also see that we can toggle between networks. And right now we're only given these networks, but later on we're going to be adding the Matic Mumbai testnet as well as the main Matic network. But now we're kind of ready to go. So like with this account that has been created, we can now go ahead and get the private key for the account that we're working with. So to do that, you can go here to your browser extension and you can click on this here and say, I want to go to view account details. And then you can click export private key. And I'm going to go ahead and copy this private key. And we're going to go back to our text editor. And I'm going to create a file called .secret. And .secret is just going to hold this value. And then what we're going to basically do is we're going to go ahead and require file service. And this is a utility that allows us to read from the local file system. And I'll say private key. And we'll say fs.readFileSync. And here we'll say .secret. And we'll just say .toString. And now we have a reference to our private key. And then we can go ahead and paste that here. So now we have our setup. So when we deploy these contracts to Mumbai, to mainnet, wherever, we're going to be using this this account from here. And then later on, we're going to actually go get some test, Matic, and to use that to deploy. And if you want to actually deploy to mainnet, you'll probably need some real Matic. So if you don't have any, don't worry about that. You don't really necessarily need to get to that very last step. But we will be deploying to the Mumbai test network with test Matic that we're going to be getting from a testnet faucet. So with that being said, I think we're kind of finished setting up our Hardhat config. And from there, we can go ahead into contracts and start writing some Solidity. So in contracts, I'll go ahead and create a file called nft.sol, as well as a file called nftmarket.sol. I will go ahead and delete greeter because we're not going to be using that, and close out these other files. And now we're ready to go. All right, so we're going to go to nft.sol, and here we're going to go ahead and set our license. And you must set some license comment here at the top. And here we're going to kind of set our license as MIT. You can do Apache, whatever you like. Next, we'll go ahead and set our version to 0.8.4 to kind of match what we had in our Hardhat config there. And now we're ready to go ahead and declare our contract as well as do our imports. So the first imports that we want to work with are going to be for OpenZeppelin. And we're going to be using, like I mentioned earlier, the ERC721 standard. And we can kind of just import that directly from at OpenZeppelin/contract/token. And this is going to recognize our node modules where we've npm installed or yarn added the OpenZeppelin/contracts package. So that's the ERC721. We also want to import the extension for ERC721 storage. Now this gives us an additional function called set token URI that allows us to set, like it sounds, the token URI. And this is just going to be giving us all of the functionality out of ERC721 in addition to that. And then finally, we want to import the counters util. And this is just a really easy to use utility for incrementing numbers. So you could write this functionality yourself, but this is a really nice and consistent way that's recognized in order to do that. So next we'll go ahead and define our contract. And we're saying contract NFT is ERC721 URI storage. So that means we're inheriting from we're inheriting from ERC721 storage, which actually itself inherits from ERC721. You're going to get like maybe an error for now, a warning, because we haven't finished writing our code yet. So don't worry about that. The next thing we want to say is we want to use the counters utility. And we're going to say using counters for counters.counter. And now we're going to be able to kind of use the counters.counter to declare a variable that we're going to call token IDs. Token IDs is going to allow us to keep up with an incrementing value for a unique identifier for each token. So when the first token is minted, it will get a value of like 1. When the second token is minted, we'll increment that and we'll give it an ID of 2. And then using counters, it will allow us to continue incrementing these token IDs. And then finally, we're going to have a variable called contract address. And this is going to be the address of the marketplace that we want to allow the NFT to be able to interact with, or vice versa. So for instance, we want to be able to give the NFT market the ability to transact these tokens or change the ownership of the tokens from a separate contract. And the way that we do that is we call this function set approval for all. And here we're going to be passing in the value of the contract address, which we're going to be setting here in the constructor. So let's go ahead and write the constructor. The constructor is going to be taking in the marketplace address as the only argument. And then we're setting the contract address as the argument of marketplace address. So when we deploy this contract, we need to pass in the address of the actual marketplace. So we're going to be first deploying the market, and then we're going to be deploying this contract. And then now we can reference the marketplace address anywhere within this contract by referencing the contract address. All right, so the next function that we're going to go ahead and create is called create token. And this is going to be the only function actually that we have in this contract. And this is going to be for minting new tokens. And the only value that we get passed in here is the token URI. That's because we don't need to pass in the marketplace address because it's already stored here. We don't need to pass in the ID of the token because that's already being kept up within the smart contract. We also know who the person is invoking this because it's a transaction, and we're going to have the message.sender available. So we have a lot of metadata available, even though we're only passing in the token URI. So the first thing that we want to do is we want to increment the token IDs. So we're going to call token IDs.increment, and this is going to go ahead and increment the value starting off at 0 and then going up from there. We then create a variable called new item ID, and this is going to get the current value of the token IDs. So let's say when we deploy this contract, it will be 0, and then the first token ID will be 1. And then the second token ID will be 2, so on and so forth. The next thing we're going to do is go ahead and mint the token. So we can call underscore mint, passing in the message.sender as the creator and the item ID as the item ID. We now want to set the actual token URI. We do that by calling underscore set token URI. This utility or this function was made available to us from ERC721 storage. Here we're passing in the item ID as well as the token URI. And then finally, we want to go ahead and set approval for all, passing in the contract address and saying true. And this is basically going to give this token or give the marketplace the approval to transact this token between users from within another contract. If we did not do this, we would not be able to do this from any other contract. And then for the purposes of our front-end application, we're going to return the item ID. That's because if we do decide to interact with the smart contract from a client application, the way that this is going to happen is we're typically going to mint the token and then set it for sale in a subsequent transaction. And to put it for sale, we need to know the ID of the token. So by returning it, we can kind of get a hold of that on the client. So that's it. That's the NFT contract, smart contract, and we're done there. We can go ahead and save that. And now we can go ahead and go to the NFT market. Now, the NFT market is going to be quite a bit of code. So this is going to be a bigger contract than the one we just created. So let's go ahead and start writing some of this code. We're going to go ahead and do the same things that we did before where we set the license as well as the Solidity version. We also want to import the counters as well as the ERC721. And then we're going to have one new import from OpenZeppelin called Reentry Guard. And this is a security mechanism that is going to give us a utility called non-reentrant. And it's going to allow us to kind of protect certain transactions that are actually talking to a separate contract to prevent someone from hitting this with multiple requests or multiple transactions and kind of, doing shady things. And so it's kind of a security control that prevents re-entry attacks. So we can use this non-reentrant helper whenever we want to kind of like implement that functionality. And we're going to be doing that on any function that talks to a different contract. All right, so the next thing we want to do is declare our contract. And we do that by saying NFT market is going to be the name of the contract, and it's inheriting from reentry guard. And now we can go ahead and start writing the code for this contract. Similarly to how we used counters in our last contract, we're going to use the counters as well here. And the two counters that we're going to be working with are going to be for the item IDs, and that's going to be for each individual market item that's created. And then we're going to also have a counter for the number of items sold. Now, the reason that we need to keep up with the number of items sold is because when you're working with arrays in Solidity, you cannot have dynamic length arrays. So you need to know the length of the arrays. So a few of the arrays that we're going to be working with are going to be the number of items that I've bought myself, the number of items that I've created myself, and the number of items that are currently not sold. We're going to need those numbers because we're going to be returning those values. And in order to kind of do that, we can either map over the arrays and kind of like check for each individual value and kind of like do something there and kind of determine that on the fly. Or in this case, we're going to keep up with the number of items sold. Doing this is going to give us a few different values. First of all, we're going to know, of course, the total number of items is going to be the item ID's value. We're also going to know the number of items sold, obviously, if we're keeping up with that. But we can also calculate the number of items that have not been sold. So when we want to create a view on our NFT marketplace items, we can say, oh, we know that there's 100 items that have been created, 30 have been sold. That way, we can return an array of 70 items that have not yet been sold. So when we create that array, we know the length of that array. Hopefully, that'll make more sense. If it doesn't make sense now, it'll make more sense later. Next, we want to go ahead and create a variable for the owner of the contract. And here we're going to go ahead and just set that as a value called owner. And the reason we want to set this is that we want to be able to kind of determine who's the owner of this contract, because they're going to be making a commission on every item sold in the way we're writing it now. This doesn't have to be that way. You can calculate and program all types of different ways for different parties to get paid. But I think a really interesting way of doing this is to kind of charge a listing fee. And then anyone that decides to list an item has to pay that listing fee. And then the owner of the contract makes commission on everyone else's transactions. All right, so we're setting the owner there. And then we're also setting our listing price. Now, in our case, it's going to be 0.025 of the value of the token that we're deploying on to that network. So when I say 0.025 Ether, this is really just kind of saying, when we're working with Ether, it's 18 decimal points. So you could kind of say, think of like if we were working with all of these different decimal points, we could use that number and talk about these values in Wei or Gwei. And those are different values that you kind of typically work with. But I think it makes a lot more sense when you're working with these extremely long numbers to kind of use that top level value. In our case, we're just saying Ether. This part is a little confusing though, because we're deploying to Matic, right? We're not using Ether. But either way, the API that we're working with is kind of the same. And you could consider this Ether actually being a Matic, which also has 18 decimal points. So, for the listing price, 0.025 Matic would be worth about 2 cents, I would say. Like, let's say one Polygon or one Matic's worth $1 today or something like that. That'd be something like 2 cents. So you might bump this up or down. If this was Ether, this would be a big listing fee. So yeah, that's just some things to kind of like think about and take into consideration. So for the constructor of this function or this contract, we want to set the owner as the message.sender. This is basically saying the owner of this contract is the person deploying it. And that's going to basically be the contract address that we deploy this with. All right, so we're setting the owner. The next thing we want to do is we want to define a struct for each individual market item. You can think of a struct like an object or a map in other programming languages. Essentially what we want to do is we want to have like, a value that holds other values as a map. And we're going to have like this key value pair where we're going to have an item ID as an item ID, and NFT contract is like, the contract address, token ID is like, the ID of that token, so on and so forth. And we have these different values that we're going to keep up with. We have a Boolean for whether it's sold or not. We have an integer for the price. We have an address for the owner. We have an address for the seller, so on and so forth. All right, so we have our market item struct, and now we want to create a mapping for our market item. So we want to start keeping up with all of the items that have been created. And the way that we can do that is we can basically have a mapping where we're passing in an integer, which is the item ID, returns a market item. So if I create a new market item, that item ID is 5. I want to be able to kind of go and fetch that market item based on that ID. This mapping allows us to do that, where we can kind of keep up with the item IDs, and all we need to do to fetch each individual market item is know the ID of that item, and that will return all of this stuff. All right, so the next thing we want to do is have an event for when a market item is created. And this is going to match, this event is going to match the market item itself pretty well. So we have our item ID, contract, token ID. You can kind of see the same things here. And this is just a way for us to emit an event anytime someone creates a new market item. And that way, you typically do this if you want to have a way to kind of like listen to these events and things like that from maybe a front-end application. So I'm going to kind of maybe close those up a little bit. We're going to keep going. The next thing I want to do is have a function that returns the listing price. So when we deploy our contract, we don't actually know on the front end how much it is to list an item. So we need that value. Of course, we could basically just hard code it, but this is a better way, I think, of doing it. This way we can actually just call the contract, get that listing price, and make sure that we're sending the right amount of payment across the wire when we're doing that. All right, so we have our base configuration kind of set up. Like we have one basic function called getListingPrice. Now we need to have two functions for interacting with the contract. One is for creating a market item and basically putting it for sale. And then the other is for creating a market sale for actually buying or selling, an item between parties. So the first function that we'll create is the function for creating a market item. So the three arguments that we have coming in here are going to be the contract for the actual NFT. So this is going to be the contract address for this, wherever we deploy this. We're also going to need to pass in the ID for the token from that contract. And we're also going to pass in the price that that token is being put up for sale. So I define the price as a user, or whoever is putting an item for sale defines that price, typically on like a client application, and we're passing that in as an argument. And then now we can deal with that here by storing that. We're also using this non-reentrant, and the non-reentrant is going to, again, basically, prevent a reentry attack. All right, and that's called a modifier, by the way. So we're using that non-reentrant modifier. So the first thing we want to do is we want to require a certain condition. The condition that we want to require is that the price must be greater than 0. So we don't want anyone, of course, listing something for free, at least one way, which is like almost literally nothing. But let's just say it's that. That's one from 18 zeros, the very bottom of that. So, of course, something real world might be something like, at least 0.1 ETH is what a lot of different applications use. And Matic, it might be, 5 Matic, which would be, the way you would calculate that would be something like, I guess, 5 ETH in our contract. So yeah, just keep that in mind. This is a really just basic example to kind of show you some ideas though. We also want to require that the user sending in this transaction is passing in the required listing price. So when I create this market item, I need to send along some payment to pay for the listing. And this is going to be locked into the contract. And then upon transaction of someone buying or selling, we want to then transfer that value to the contract owner. So we're just requiring that the person is sending in the listing price along with the transaction. The next thing that we're going to do is we want to, again, increment our item IDs, and then we're going to go ahead and create a variable called item ID. And this is going to be the ID for the marketplace item that is going for sale right now. And then we're going to go ahead and create our mapping for this market item. So here we're going to go ahead and create the market item as well as set the mapping for that market item. So we're saying ID to market item ID. So in this case, it might be ID to market item 1. And then we're creating the market item itself, and we're setting all of the values here. So the item ID is coming from here. The NFT contract is coming from the argument here. The token ID is coming from the argument as well. The person that is selling this is the message sender, which is available in the transaction. The owner is being set to an empty address, because if you can go down to our market item struct, you'll see that we have a seller and an owner. So the owner right now is no one, because the seller is putting it for sale and no one owns it at this point. So we're setting it as an empty address, and the way that we do that is passing in address with a 0 value. We're also setting the price, and we're setting the Boolean of if it has been sold to false, because if it's just being put up for sale, then of course it's not sold yet. So we have our ID to market item, and we're setting, we're creating our first market item at this point. And then we now want to transfer the ownership of the NFT to the contract itself. Because right now, the person that is writing this transaction owns this, and we want to transfer that ownership to this contract. And then the contract is going to then take the ownership of this item and transfer it to the next buyer. Of course, you could have functions in there that allow people to go in and cancel their marketplace items or whatever you would like. There's a bunch of things you can do. Hopefully, the things that we're talking about today will start getting your brain, thinking about different use cases and scenarios. But the way that we do that is we use that ERC-721 passing in the NFT contract, and we transfer from the message.sender to the contract itself, and then this is the token ID. And this is a method that's available on the ERC-721. So once you've imported this from OpenZeppelin, you'll have that method available. And then finally, we just want to omit the event that we created earlier, where we're going to say a market item has been created. And here we're passing in the item ID, the contract, the token ID, message sender, all of the different values that we basically kind of set here. We're setting there. And that's the end of our function. So that was a pretty big function, a lot of stuff going on there. If I go ahead and kind of like minimize that, whoops, that's probably not the right one. Here we go, minimize that. You see that we have two functions now, one for listing, getting the listing price, one for creating a market item. And then the last function we want is for creating a market sale. And this is going to look a little similar to the create market item in the sense of, where we basically are using the non-reentrant modifier. We are also using the contract address as well as the item ID. We don't need to pass in the price because the price is already known in the contract. So the first thing that we're going to do is go ahead and create a couple of variables based on our arguments here. So we want to go ahead and get a hold or get a reference to the price. So we're creating a variable called price. And the way that we can get that is just using the mapping. So we're going to say ID to market item using the item ID, and we're getting the price. Doing the same thing with token ID. We want to know the actual token ID because we have the item ID, and of course that isn't always going to match the token ID. And then we can now require that the person sending this transaction has sent in the correct value. Because in this transaction, if I set this thing up for sale for like 100 Matic, then we're expecting that message value to equal the price. And if it's not, we're going to say, please submit the asking price in an error message. Next, we want to go ahead and transfer the value of the transaction. So how much money was sent in the transaction. We want to go ahead and transfer that value to the seller. So I'm the seller. I'll put this thing up for sale for, again, like 10 or 15 Matic. The value that's now passed in is going to be available in message.value, and we're going to go ahead and transfer that to the owner's address. The next thing that we want to do is we want to go ahead and transfer the ownership of this token to the message.sender. So we're saying we want to transfer from this contract address to the message sender, and this is the token ID. So this is actually transferring the ownership of the digital good from the contract owner, or the contract address, I would say, to the buyer. So we've done two transactional things here. We've sent money to the seller. We've sent a digital asset or an NFT to the buyer. The next thing we want to do is we want to go ahead and set the local value for the owner to be the message sender. And in this case, we're kind of just updating that mapping here. We're going to go ahead and set this value to being sold using that same mapping. We also talked about keeping up with the number of items sold. So let's go ahead and increment the items sold by 1. And finally, we want to go ahead and pay the owner of the contract. So the way that we can do that is we can say owner.transfer, and we're going to pass in the listing price. So now we're transferring the amount that that person had listed the item for to the contract owner. So this is the commission that the person running this marketplace might start making residually. So, we're covering a lot, but I think, all important stuff. So we've now finished writing the function for creating the market item as well as the market sale. So I think we can go ahead and move on to the next step. And the next 3 functions are going to be fairly similar. We basically want to have different views, I would say, or different selection sets of our NFTs. We want to have a function that returns all of the unsold items. We want to have a function that returns only the items that I've purchased. And then I want a function that returns all of the items that I've created. This way we can have like a profile view for all of the things that I've created. We can have a view for all the things that I've bought. We can have a view for all of the unsold items, which I think are kind of 3 main views that you might consider having in an app like this. So we'll go ahead and create the first function, and here we're calling this fetch market items. This is going to be available from the client application, so it's public. It's a view. It's not doing any transactional stuff, and this returns an array of market items. So let's go ahead and start writing the code for this. And the first thing that we want to do is we want to go ahead and create a variable called item count. And this is going to be the total number of items that we have currently created. And then using the item count, we can go ahead and get an unsold item count by subtracting the number of value that we have as the total items that have been created, subtracting the items that have been sold. So let's say we have 100 items here and we've sold 30. That means the unsold item count is going to be something like 70. And then finally, we want to keep up with the local value for incrementing a number, essentially, because we're going to be doing we're going to be looping over an array, and we want to keep up with a number within that array, within that loop. So in our case, we're going to be basically looping over the number of items created, and we want to increment that number if we basically have a empty address. That basically means if the item has an empty address, that means it has not yet been sold, and we want to populate an array with that unsold item, and then we want to return that item, because again, we only want to return from this function the number of unsold items. So to do that, let's go ahead and create an empty array called items, and this is going to be the length of unsold item count, and the values in this array are going to be of market item. So we're saying we want market item memory items is equal to a new array, and it's going to be, you know, the length of unsold item count. And that's kind of why we needed to keep up with that value earlier. All right, so now we're going to loop over the number of items that have been created, and we're going to go ahead and first check to see if this item is unsold. And the way that we can do that is we can use the ID to market item map, looking for the owner value, and we can look for the address to be an empty address. So the owner is going to be an address already. And if you remember when we created the mapping for creating a new market item, we set the address to an empty address to begin with. The only time this address is populated with an actual address is if the item has been sold. So here we can detect all of the unsold items, and what we want to do is we want to insert the item into this items array, and we also want to increment this current item. All right, so we're going to now go ahead and create a new variable called current ID, and this is going to be the ID of the item that we're kind of like interacting with right now. We're going to now go ahead and create a value called current item. That's going to go ahead and get the mapping of the ID to market item, passing in the current ID. And this is going to give us a reference to the market item that we want to go ahead and insert into that array. And we now insert that item into the array by saying items current index, which is going to be this value here. So we're going to start off like an empty array. We're going to start incrementing and, like, you know, setting that value there. So we're setting the value of the items at this index to be the current item. And then finally, we need to increment the current index. So, you know, we're going to say current index plus equals 1, or however you want to do that. And then now we're basically mapping over, or we're looping over the number of items that we have. And if the item has not been sold, we're inserting it into this items array. And then now we can return this array from this function. And now we should be good to go. So I think that's the only thing we need to do at this point, just making sure I put that return value the right place. So that's quite a bit. You know, we did a lot in that function, but we're going to be replicating a very similar functionality a couple of more times. So kind of get used to that. The next function that we're going to be returning is a function that returns only the NFTs that the user has created themselves. Or actually, let's do the one where the function for returning the NFTs that the user has purchased themselves. So this function is called fetch my NFTs. Similarly to how we kept up with the total item count, we're also going to be doing that, where we kind of look for the item IDs.current. We're also going to keep up with a new variable called item count. And we need to have another counter that we're going to be basically keeping up with, because basically we have not been keeping up. For instance, if I've created an item myself and I want to fetch the number of items that I've created, we don't really have a function that will tell us that, right? The only values that we're keeping up with as far as like counting the number of items created, or the total number of items created and the total number of items sold. But we're not keeping up with that number for each individual user. So the way that we can get that number is we can basically loop over all of the items, and we can say if the ID to market item owner is equal to the message.sender, we want to increment this item count by 1. So by doing this, we can basically map over or loop over every single item in the array that we're going to be working with. And we can say, okay, I've created or I've bought, 5 or 6 items or whatever, or I own 5 or 6 items. So that's the number we're going to be able to then populate that array like we did earlier. So now using that array, we can say, just like we did earlier, where we have this items array, we can now use the item count as the length of the array, whereas before we were using the unsold item count. In this function, we're using the item count. So now we know the item count, like for me in this case, we're fetching the NFTs that I have purchased. If I've purchased 5, then this will be incremented by 5, and I can have like 5 items. And then really the rest of this is going to be very similar to what we did before, where we're kind of mapping over the total item count. And then we now are going to be checking to see if the owner address is equal to the message sender, which basically means it'll be mine. Then we want to go ahead and do our work here. Here we're going to go ahead and get the current ID, which is going to be the item ID. We then want to go ahead and get the current reference to the current item. And then finally, we want to go ahead and insert that item into the array. And then we want to go ahead and increment the current index. And of course, I guess we could have used counters here because we've been using counters before, but either way, it works either way. And then we're just going to return the items. So we have a function now for fetching only the NFTs that you have purchased. We have a function for fetching the NFTs that have not been purchased by anyone. And then the last function that we want to create is for creating an array or returning an array of the NFTs that a user has created themselves. So this will look very similar to that last function, where instead of looking for the owner to be the message.sender, instead we're going to look for the .seller to be the message sender. So we're going to go ahead and say, have a for loop here. And we're checking to see if this item .seller is equal to the message sender. Then we increment that item count by 1. We create our market item array here of items. We go ahead and loop over all of the items in the project. We check to see if the seller address is equal to the message.sender. If it is, that means I am the person that created this item. Then we can go ahead and get the current item and insert that into the array. And then we can go ahead and increment the current index. And then finally, we can return the items. All right, so that's a pretty overwhelming, amount of code that we just wrote. So that's a pretty big smart contract. It's doing a lot. I would say if you got confused or anything like that, refer to the code reference below and maybe copy and paste some of this. But it is important for you to kind of maybe understand what is going on, because it's a core piece of really building out these types of applications, is understanding not only the front end part, interacting with the contract itself, but also understanding the functionality here and maybe writing some of it yourself in the future. So the next thing we might want to do is go ahead and test this out. So we're going to write one test, and then we're going to start building out our front end. So I can go to test/sample test, and we can go ahead and start writing our function for our test. So we don't really need anything having to do with greeter. Greeter is not even there anymore. So we might say like NFT market. And then we might say something like it should create and execute sales, market sales. So the idea here is we want to kind of like simulate deploying both of those contracts, creating a new NFT, putting that NFT for sale on the market and then purchasing it from someone else. So to do that, we're going to go ahead and say we want to get a reference to that market contract. So I'm going to say get contract factory NFT market. And here we should have our contract / NFT market. So we're good. And then now we can go ahead and say we want to wait for the market to be, and deploy the market and wait for it to be deployed. So here we're going to go ahead and say await market.deploy. And then we're going to wait for it to finally finish being deployed. And then we're going to go ahead and get a reference to the address from which it was deployed. Because if you remember earlier in the constructor of the actual NFT market, we need to go ahead and pass in the value of that market address for our NFT constructor. So now we'll go ahead and deploy the NFT contract. So we'll go ahead and get a reference to that. We'll pass in the NFT market. We'll go ahead and pass in the market address to the constructor of the NFT. We'll now await for that to be finished deploying, and then we can get a reference to the NFT contract address as well. So we have both a reference to the market address as well as the NFT contract itself. Now we're going to need a way to know how much the listing price is. So we already have deployed our contract so we can start interacting with it. So here I'm going to go ahead and get a reference to the value of the listing price. And the way that I can do that is I can say await market.getListingPrice. And then I can go ahead and turn that into a string because we're going to need to have that as a string in order to be interacting with it. Next, we'll go ahead and create a value for the auction price. So this is going to be kind of like how much are we selling our items for. So, in our case, we're working with Matic, so we could say something like 100. It's not that much. So we can kind of use this utility called ethers.utils.parseUnits. And this allows us to work with these whole units as opposed to working with way, which are 18 decimals. So what we're going to go ahead and do is create a couple of different tokens. We'll put them up for sale in just a moment, but first we have to actually create them. And to create them, we can interact with the NFT market contract. The NFT contract. And here we're going to say nft.createToken. We're going to pass in the URI of our token. And then we can go ahead and list these two tokens on the actual market now that they're created. So we've created the tokens. Let's go ahead and list those. And the way that we're going to do that is we're going to call market.createMarketItem. We're going to pass in the contract address of the NFT deployment. We're going to pass in the token ID, which remember we're starting with 1 and we're incrementing up. So we should have this should be number 1 and this should be number 2. We're passing in the auction price of 100 Ether, but in our case we'll be working with Matic. And then we're passing in the value that is going to be passed in for this transaction being paid to the contract owner is going to be the listing price. So we need to make sure that value is there as well. So we're passing in the listing price. And now we've already deployed, or now we've already kind of created all of these different transactions. Let's now think about how we can get different addresses from different users theoretically. So in a real application, the users would be using MetaMask or their wallet and kind of interacting with it from some address. But in a testing environment, you can actually get a reference to a bunch of test accounts. So for instance, when we run our Hardhat node, we're going to be given 20 different local accounts to work with. And you can also do that using the Ethers library. You can get a couple of different basically test accounts. So in this case, you can call ethers.getSigners. This returns an array, and you can have as many items that you want to kind of like destructure out of this array as you like. So I could say like 3rd address, 4th address, or whatever. Now by default, if we are deploying, we're going to be working with the very first item in that array. So like by default, we're not really specifying an address. We're just deploying stuff. And that's going to be using the first address. So now we want to basically specify a different address. So we're kind of like just ignoring that address by using an underscore. And now we're going to get a reference to the buyer address. And the reason we want to do that is we don't want the buyer to be the same person as the seller, right? The seller is like this underscore you could think of, and then the buyer is this new buyer address. So now we can go ahead and say we want to use this buyer address to connect to the market. And then we want to create a market sale, passing in the contract address, the ID of the token, and the value of the auction price, which in our case, I think we set it 100 units, or in our case will be 100 Matic. All right, so what we've done here is like we've created 2 NFTs, we've placed 2 NFTs on the market for sale, and then we've sold an NFT to someone else. So the last thing we might want to test is querying for these market items. So we can do that. I can go ahead and say we want the items. We want a variable called items, and we want to go ahead and set that to market.fetchMarketItems. And then we might just want to go ahead and console.log these items. So here we kind of have our function where we're calling fetchMarketItems, and then we're going to log those out. So that's quite a bit of code as well, but it's a pretty interesting test, and I think it kind of like essentially tests out all of the main functionality that we want to work with. So let's go ahead and test this out. So to do that, we can run our tests. We can open our terminal, and from here we can run the test by running npx hardhat test. And this should take just a second, but essentially what we're doing is running all of that script that we just wrote. And if the test passed successfully, you should see something like this, where it says should create and execute market sales. And the only item that we've returned is this array of items, and these are the unsold items. And this makes sense because we've created 2 items, we've sold 1, and now we're only returning a single item. Now, what we're seeing come back though is like a lot of weird values. We see big number, we see values that we're not used to working with. So there are utilities that we can work with, or there are even functions on some of these values that we can work with. So for instance, we can turn a big number to a string that is human readable. And we need to do that on the client to visualize a lot of this information. But we can also kind of update our tests to do this as well, just to kind of get an idea around some of the things that we're going to be doing on the client. So what we basically want to do is, let's say we want to map over all of these items, and we want to update the value of them. So what we might want to do is we might say, okay, we want to repurpose the value of these items. So we might say, okay, we want to set these items to be the result of this map, where we're going to kind of map over all of them. And we want to do this asynchronously, so we're going to say promise.all, and this allows you to do an asynchronous mapping. The first thing that we want to do is we want to get the token URI, and we can do this by calling nft.token URI, passing in the ID, and this gives us the actual URI of that value. And then we can now go ahead and create a new reference to the item, where we can say we want to just only return certain values. So we want to return the price, the token ID, the seller, the owner, and the token URI. So we have the token URI that we've gotten by calling the NFT contract. We're also turning this big integer, or this big number, into a string for the price as well as the token ID. We're defining the seller and the owner by just the address. So we're kind of we're defining this new item value, and then we're returning it. So now when we visualize this, let's go ahead and run this test one more time. This should make a lot more sense when we actually see it. So now we're seeing, okay, this price is this number, and don't forget we're working with this 18 number value, which is way. So that looks really big, but it's exactly what we listed it for. I think in our case we listed the value again as 100 Ether. So this is like 100 with 18 zeros. We have the token ID, which is 2. We have the seller address, and we have the owner address. So the owner address is an empty address, so it's 0x and all these zeros. And then the token URI as well is like very, very easy to read. So now we've updated this data, and it makes it a lot easier for us to kind of understand. So it looks like all of our code is working. So now we can go ahead and build out the front end, which is really great because we've done a lot of work so far. So let's keep this going. So for the front end, the first thing we might want to do is go to our pages and see the different pages that we have now. And maybe we'll go ahead and run the app. So let's go ahead and do that. So to do that, I can go ahead and run npm run dev. And we should have a server running at localhost 3000. So I'm going to go ahead and open up my browser at localhost 3000. And we see our basic Next.js app. Okay, so we have our app running. Let's go ahead and see some of the files that we have. So the main files that we have are in this pages directory that we're going to be working with for the UI. We have our index, which contains everything that we see here. And then we have our app.js, which a lot of times is used for things like layout and navigation. So for index, we might just go ahead and delete a lot of this stuff for now. And we don't need these, just go ahead and get rid of all that stuff. Let's just say H1 home, pretty simple. If we go ahead and update now, we see that we have that, which is great, because we're going to need to update this a lot in just a moment. For us to actually start building out some of our UI though, we want to go ahead and start with app.js, and we want to create a layout. And we want to do a layout which is going to basically, apply, first of all, mainly our navigation. And in our case, the navigation is going to have a little bit of styling and stuff like that, but we're also going to be linking to other pages. So in order to link to other pages in Next.js, we need to go ahead and import the link component from NextLink. The next thing, instead of just returning the component that is being rendered, we want to go ahead and wrap this in a div, and now we can apply some navigation. And we're going to be styling our navigation with Tailwind. So this is going to be the first Tailwind code that we see so far today, I think. So here we have our nav. We have the class name set here. And basically this is going to say border B, which is border bottom, and padding 6. So this is just going to be setting some overall border at the bottom of 1 pixel, and then padding of 6. So for our title of our application and our navigation, we can go ahead and give this a title. We're going to call this Metaverse Marketplace, or you can call it whatever you like. And we're going to set the text to be 4XL, and we're setting the font to be bold. And these are using these class names from Tailwind. The next thing we're going to do is we're going to go ahead and create a div to hold our links. And we want to have display flex. So we're saying flex, and then we're setting the margin top of 4. And this is going to apply, of course, to all of the links that we're about to create here. The first link that we want to create is for a link to go home, so like a root link. And we're setting the value to be home. So that way we can navigate from different pages and back to the home page. We're going to also create a link for creating a new item. So we have /create item, and you're going to see that for the most part, I think we have the same styling for each one of these. So I think margin right 6 would be making this consistent. And then we're setting the text color to be pink. This could be whatever color you want, so do what you like. So we have a page for creating an item. We have a home page. We have a page for viewing our own assets. So these views for for listing your own assets and for the creator dashboard are going to be calling those functions that we were working with in our Solidity code earlier. So my assets shows you the items that you've purchased. And then we're going to have this creator dashboard. And /creator dashboard will be the creator dashboard. This shows you the items that you've created, but it also shows you the items that you've sold in the marketplace. So this is a really great view, I think, and it makes a lot of sense. So if I go ahead and save this and I go back to my app, we now see that we have our title there. If we try to click on any of these pages, it's going to break because we haven't created those links yet. But if we go back home, it works. So we have some user interface going and we're getting there, right? So that's great. The next thing we want to do is in our homepage, we want to go ahead and update this to go ahead and fetch the assets from the marketplace and show them. Now, right now we haven't created anything yet, so it's going to be an empty array, but let's go ahead and write the code to make all this work. So the first thing we want to do is go ahead and update our imports. So we don't need this styles import anymore. Instead, we're going to go ahead and import the Ethers library from Ethers. We're going to go ahead and import use state and use effect from React. These are hooks. Use state allows you to keep up with local states. Use effect is a hook that allows you to invoke a function when the component loads. Axios is a data fetching library, and Web3 modal is a way for us to connect to someone's Ethereum wallet. Now, when we deploy our project, we're going to need to have a reference to our marketplace address as well as our NFT address. So to do that, let's go ahead and create a file at the root of our project called .config. And here we want to go ahead and have an export const NFT market. Actually, this needs to be config.js, sorry. So NFT address is equal to an empty string. And we also want to have a const for the NFT market address. And then in our file, once we've deployed, we're going to have those values. And then in our file, we can go ahead and import those here. So now we have a reference to our addresses there, and we're ready to keep on going. So next we need our ABIs. So our ABIs are essentially a JSON representation of our smart contract, and it allows us to interact with it from a client-side application. Now, when we ran npx hardhat test earlier, Hardhat automatically looked in our contracts and compiled them and put them in a folder called artifacts. So if we go ahead and delete that folder, like it's already there, but let's say we deleted it and we wanted to compile it again, we could either run another test or we could say npx hardhat compile, and then this would go ahead and compile those. And whenever we compile those, we are creating some artifacts that we're going to be able to reference within our client application, and we see that we have this artifacts directory here. So what we now want to do is go ahead and import those artifacts and reference them in this file here that we're working in. So the first thing we'll import is the NFT ABI as well as the NFT market from the artifacts/contracts/ nft.sol/nft.json, and the same thing with the others. So don't really worry about what's going on in there. This is just how the Ethers client is going to know how to interact with the contract by using these ABIs. So we don't really need to kind of like do anything other than reference those later on in our project. All right, so we've imported our reference to our NFT and our market ABI. Let's go ahead and create our initial state that we're going to be working with in this component. So we're going to have two pieces of state. First of all, we're going to have an empty array of NFTs, and then we're going to have a function to reset that array of NFTs. So when the app loads, we're going to have no NFTs. We're going to then call the smart contract. We're going to fetch that array, and then we're going to update the local state. We're also going to have a loading state and a set loading state functionality. We're having the loading state as a variable, and the set loading state is going to allow us to update the loading state. And by default, when the app loads, we're going to say that the loading state is set to not loaded. And then later on, when we want to set the loading state at any time, we can like call set loading state, and we can set it to loaded or whatever we would like. But using this loading state, we can basically show or hide, our UI, and that's a good way for us to kind of keep up with where the application currently is, I would say, in the life cycle. All right, so one of the functions that we're going to need to create is called load NFTs. And this is going to be where we call our smart contract and fetch our NFTs. And typically you want this function to be called when the app loads or when the component loads. So the way we can invoke this function when the app loads, like I mentioned earlier, is using this useEffect hook. So let's go ahead and call useEffect. And here we're going to go ahead and just return, or not return, we're going to go ahead and invoke the load NFTs function. All right, so the component loads, load NFTs gets invoked, and here we want to actually go ahead and talk to the smart contract and load our NFTs. So the way that we're going to do that is we're going to be working with one of the Ethers providers. Now, in a read operation, we don't really need to know anything about the user, so we can use a very generic provider called the JSON RPC provider. So here we kind of say new ethers.providers.json RPC provider. And now we can go ahead and configure the contract by saying ethers.contract, passing in the address, the ABI, as well as the provider. So here we're taking a reference to the actual NFT contract, but we also want to go ahead and get a reference to the market contract. Because what we're basically going to do is we're going to fetch the market items, and then we need to map over the market items, and we want to get the token URI by interacting with a token contract. So we basically need both of those. The next thing we want to do is actually go ahead and get the data. So we're going to say market contract.fetch market items, and this correlates directly, if you remember, in our contract where we have fetch market items. This is the function that we're calling. So we're returning all of the unsold market items. And this is going to be returning that array. And like we did before, we want to go ahead and map over all of those items. All right, so we're going to say create an item array called items. We're going to say promise.all, and we're going to say data.map, and this is going to be asynchronous because we have a couple of asynchronous operations. So the first thing we want to do is we want to call the token contract, and we want to get the token URI. But one additional call that we want to make is that with that token URI, we want to get the metadata from the token. So when you're working with IPFS, we're going to be uploading essentially kind of like a JSON representation of this NFT, which is going to hold different information. So you're going to have like the name of the token, the description of the token, and an image, which is kind of the reference to the actual image and or video or something like that. So to get that, we're going to call axios.get, passing in the URI. So the URI might be something like HTTPS, like some IPFS endpoint, like whatever the ID is. So by calling that, we're going to be able to kind of get the value that is returned from that. So we have that meta, and basically we want to use that in just a moment. And the next thing we're going to do is we're going to go ahead and create a value called price. And this is going to be something that we set in the item property. So we're going to have like an item object. So let's say item is equal to like object or something like that. And then here we want to return the price as one of the values. But we want to format the price, because when it comes back, it's going to be coming back in a format that we can't really use. So to format that, we can call ethers.utils.formatUnits, passing in the price to string and then saying ether. And this way we can like show that main value of like 5 or 10 or 20 or 100 Matic, as opposed to like 18 zeros appended to that. In addition to the price, we want to return a couple of other values. So we want to set the token ID. We want to set the seller. We want to set the owner. We want to set the image, which is coming off of that metadata. We want to set the name, and we want to set the description. So this way we can kind of represent the NFT in a very visual manner. And then here we're just going to return the item. So we're mapping over the items array, and we're kind of like forming it into a very, nice piece of data. Like we're kind of like mutating the data and setting it, resetting it, and then we call set NFTs, and this is going to go ahead and set that new updated items array, and then we can call set loading state to be loaded. And what we can now do with that loading state is we can say if like loading state is equal to loaded and the NFTs.length is empty, we can basically tell the user, hey, there are no items in the marketplace. So this is essentially what we're going to be doing, what we're going to be seeing when we first run the app, because when the app loads, there are going to be no items. Now, it's just kind of a pretty basic way to kind of show the user after the app is loaded. If there are no items, then someone needs to go ahead and create one. This will be more of like a thing that the user sees the first time the app loads and no one's created anything. So we've created the function for fetching and for loading the NFTs. But in this view, the user is also going to have the option to purchase an NFT. So we're rendering that array of NFTs, but we also want to give the user the ability to buy an NFT. So we're going to create a function called buy NFT. And this is going to allow the user to connect to their wallet. So to connect to the wallet, we can say we want to use Web3 modal, and this is going to go ahead and look for the instance of the Ethereum being ejected into the web browser. And then we can say web3 modal.connect. And if the user is connected, then we will have a connection that we can work with. And we can now create a provider using that user's address or that user's connection. And instead of using the JSON RPC provider, we're going to be using the Web3 provider. And we're passing in the connection. And since we're going to be writing an actual transaction, not only do we need that user's address, but we need them to sign and execute an actual transaction. So to do that, we want to create a signer. And we do that by saying provider.getSigner. And now when we call the contract, we can now, or we get a reference to the contract, we can say ethers.contract, and instead of passing in the address and the ABI and the basic provider, we're now passing in the signer as the third argument. All right, the next thing we'll do is we want to get a reference to the price, and the price is coming in as an argument off of the NFT. So we're going to be mapping over the NFT. Again, a second ago in the load NFTs function here, we kind of had a reference to the price here. And that price is going to be available to us as nft.price. So we're going to say nft.price to string, and we're going to be parsing that. And we're basically going to be kind of like transforming that back from that basic string into a number that we can basically use here. All right, so the next thing we want to do is we want to go ahead and create the market sale. So in our contract, we have a function called create market sale in our smart contract. So here we're going to call contract.createMarketSale. We're passing in the address as the first argument, again coming from the import of the configuration that we'll set up later on. And then we also pass in the NFT.token ID. And then the value that is being sent is going to be the price. So this is going to be the money that's going to be transacted out of that user's wallet into the other user's wallet. We're going to then call transaction.wait, and this is just a way to wait until this transaction is actually executed, because maybe we want to wait for this transaction to finish and then do something. And in our case, the thing we want to do is reload the screen, because we want to go ahead and remove that NFT by reloading and calling load NFTs in our case again. So after the transaction has happened, load NFTs should now have one less NFT, because buy NFT only shows the NFTs that are not sold. And since we just sold that NFT, it shouldn't show up anymore. All right, so we now have our functionality finished as far as the actual code is there. And now we can go ahead and update our main UI. So no more. We only had two main functions. One for loading the NFTs and one for buying an NFT. All right. So the next thing we want to do is let's go ahead and create a new div with some styling that we're going to be working with. And here we're going to set the flex box and also setting the flex to justify center, so we can center the things that are happening here. Next, we're going to create another div. And here we're setting the class name as padding x of 4. And I'm setting a max width of 1600 pixels manually, like not using Tailwind. Now, you could also go into your Tailwind configuration and set this up yourself, but it's a little bit extra work. And I think like for this demo purpose, we want to kind of, say if the user has a massively wide screen, we want to stop it at 1600 pixels. And this is kind of a simple way to do that. The next thing we want to do is like we have one more, div inside this div. So we're kind of going nested now to where we have, let's see here. We have 3 levels of divs. So if I go ahead and do that, you'll see we have the main container, we have this child container, and then we have our flex container. Our grid container. And this is a cool way to kind of have a responsive design. So when there is a very wide screen, we're going to show 4 columns. As the screen gets smaller, we're going to have 2 columns. And then when it gets really small, we're going to show 1 column. So this is just a kind of a way to do, some responsive design. All right, so next we're going to go ahead and map over the NFTs. So to do that, we can go ahead and, I'll start writing this from scratch actually. So we can say nfts.map, and we're going to return, for each NFT, we're going to return, something. And not only are we going to maybe return the NFT or get the NFT in the argument, let's also get the index. And the index is just going to allow us to kind of set the key. And, there's a couple of ways to do that, but, and you can use the ID or something like that. All right. So we're going to be mapping over the NFTs. And for each NFT that's in that array, we're going to return like a div. And here we're going to set some styling. So the styling that we're going to be working with, I'm just going to go ahead and copy that here. And we're going to set the class name to, I've been using other, styling there. So just check it out. I'm not walking through every single piece of styling. But in this case, we're setting the border to be 1 pixel. We're setting some basic box shadow. We're setting rounded XL, meaning we're going to have border radius. And then we're setting the overflow to be hidden. And we're going to go ahead and display the image. So we're going to say the image source is the nft.image. We're going to then have a section to show the NFT name as well as the NFT description. So for the NFT name and the description, we're going to put this in another div with padding of 4. I'm setting a fixed height for this piece of UI here, mainly because you're going to have inconsistent, lengths here. So the NFT name might just be a single line or might be 2 or 3 lines for other NFTs. But here we want to kind of like set a fixed height so the UI looks consistent, across all of the different items. We also are setting the NFT description here. So here we're also setting the height, we're setting the overflow to be hidden, and we're setting some basic styling like for the text to be gray here, and here we want the text to be semi-bold. So this is going to show the NFT name, and this is going to show the NFT description. And the last thing that we want to show is the price. So right now we have not displayed the price, and we also want to give the user a way to purchase the NFT. So the way that we can do that is we're going to go below this last div here. And here we're going to create another container with a black background. So This will have a white background, and then this will have a black background. And here we're going to be displaying the price. So we're saying NFT.price, and then we're saying in ETH, when in reality, of course, this could be Matic, and or maybe we can just go ahead and set that here, Matic. And here we have a button that allows the user to say buy NFT, passing in the NFT, and then this, of course, is going to invoke this buy NFT function. So with all of that UI in place, we now kind of have this this component finished. So what we can now do is go ahead and test this thing out. So the one thing I did realize just now is that when I reference the contract for NFT market, I'm actually looking in the wrong directory. So here I'm saying contract/market actually needs to be NFT-market.sol. So that's kind of one fix there before we kind of go ahead and test this out and deploy this. So what we want to do now is like deploy and test the entire application. Now we're not going to be able to do the transactions just yet. We'll get to that in just a moment. But for now, we just want to go ahead and deploy the contract locally, run the node, query, and just make sure that it's kind of generally working. So the way that we can do that is we want to update our scripts folder with a file called deploy. Now we already have a sample script, so let's go ahead and just rename that to deploy, and this is going to be our deploy script. And by default we see that we have some comments. We even see that we have a basic deploy script. Now this is a pretty cool deploy script because it's essentially what we're going to be doing. So for instance, instead of saying greeter, we're going to be saying NFT market. So we can kind of just replace, greeter with NFT market, and then we might just call this like NFT market, and we might say we want to wait for NFT market.deploy, and this doesn't really need any arguments, and we can say await NFT market.deployed, and then we can say NFT market deployed to NFT market.address. So that's kind of cool. Like we can just work with that code. So we've deployed our NFT market. Now let's go ahead and deploy the NFT. So here we have NFT is being set to hre.ethers.get contract factory, passing in the NFT. We're also going to go ahead and create a reference to wait for the NFT to actually be deployed, using the NFT market.address as the argument, because we need to set that address in the NFT marketplace, if you remember. The next thing we want to do is just wait for this to be deployed. And it looks like that's already being written here for us. And it looks like it's giving us that code as well. But yeah, basically we want to say we want to console.log the NFT address as well as the NFT market address, because we need to update our config.js with those values. So how do we go ahead and deploy this locally? So let's go ahead and check that out. So to do that, we're going to go ahead and open our terminal, and I might crack open a couple of windows. The first thing we want to do is run a local node. So to do that, I can run npx hardhat node. And this will go ahead and run a local node for us. It looks like I already have something open, so let me go ahead and figure out where that is and close that. All right, we'll go here and try that one more time. All right, so we have our node running. Next, I want to go ahead and deploy our contract. So to do that, I can go somewhere like here, and I can say npx hardhat run scripts/deploy, and then we want to set the network to be localhost. Now, if this deploys successfully, we should see some transaction happening here, and then we should see that we have the contract addresses logged out here. So we have our NFT market address. So let me go ahead and copy that to my clipboard. And then we have our NFT address here. And we're now set up locally for everything to kind of work. So let's try testing this out. And to test it out on our client, we can run npm run dev again and go ahead and start up our project on localhost. All right, well, nothing exciting, but we do see no items in marketplace, and we also see no errors, which is really cool. That means we are, so far so good. We still have some work to do, so let's get back to it and continue writing the code. So the next page that we might want to work with is maybe the create item page, so someone can like create an item. So let's go ahead and do that. So in pages, let's go ahead and create a new file called create item.js. And here we're going to go ahead and let me go ahead and close some of these files that we're not using anymore. Here we'll go ahead and start off by importing the things that we're going to need. So we're going to import use state from React like before, Ethers from Ethers like before. We're importing Web3 modal like before. We do have two new imports. One is the ipfs-http-client, and this is a way for us to interact with IPFS for uploading and downloading files. We also have the use router hook from Next router, and this use router hook allows us to programmatically route to different routes using the router. It also will allow you to read values off of the route URI. The next thing we want to do is create a variable called client, and we're setting it equal to the ipfs-http client, passing in the URL here. This is an Infura URL that you can use that basically sets and pins items to IPFS. There are all types of other nodes that you can work with. You can use your own pinning service or whatever you like, but for this tutorial, this URI that I'm using here should work fine. The next thing we want to do is we want to import the NFT address and the NFT market address like we did before from our configuration. We'll go ahead and import our NFT reference as well as our NFT market reference for our ABIs. So we have our market and we have our NFT. The next thing we'll do is we'll go ahead and define our default export or our component. And we want to create a couple of pieces of local state using useState. So the first one that we want to set is the file URL. This is going to be for the IPFS file that we're going to allow the user to upload. And then we also want to create some local state for the form input. So this component allows someone to create an NFT. So we want to allow them to upload a file. We also want to allow them to set the price of the NFT, the name, and the description of the NFT. So we do that by using useState, but instead of passing in a Boolean or a string or a number or some other value, we're actually passing in an object. And this object is going to contain the price, the name, and the description values. And then the next thing we'll do is we'll go ahead and create a reference to the router using the use router hook. And we'll be using that in just a moment. All right, so we have our local state ready, and we'll create I think we have like 3 functions that we're going to be creating here. The first function that we want to deal with is for creating and updating the file URL, because right now it's set to null. And we're going to have a form input. So we can have a function called onChange, and then we'll attach this to the input handler or the input for the user's file input. OnChange is going to be invoked with an event, and this will have an event.target.files array, which will be containing one item. So we're just going to take the first item out of that array, and then we can have like a try-catch block that we can work with here. And here we'll just log out the error if there's an error. And then in the try-catch block, this is what we're going to use to go ahead and upload the file to IPFS. So we can say const added is await is equal to await client.add, and we're passing in the file. You can also do a progress like callback, and if we want to do that, we could add in this argument here, where we're saying progress, and then we can just console.log the progress of the file upload. And then after this upload is complete, we'll have reference to this added variable. And using that variable, we can now set the URL of where that file is now located, because we know it's going to be at ipfs.infura.io/ipfs, and we can say the /added.path is the path that's given to us after the upload. And then we can call set file URL, passing in that URL. And then now when we create our NFT, we know where that file lives. Next, we want to create the functions that allow the user to list an item for sale. So to do that, we need to basically have quite a bit going on. So we're going to break this up into two separate functions. We're going to have one function that allows the user to create an item and create it and save it to IPFS, which is going to be kind of the reference to the NFT. Because not only do we have that URL referenced locally, but we want to kind of upload a JSON representation of the NFT, including the name, the description, the image. So, quote unquote image. It also could be a video or something like that, of course. So we're going to have two functions: one for creating that item and saving it to IPFS, and then the other for creating the sale or listing the item for sale. So the first function we'll create is for create item. And this is going to be what lists or creates the item and saves it to IPFS. So we're going to first need to get the values from the form input. So we want to destructure the name, description, and the price. And then for some really basic form validation, we can first say, okay, if there is no name, if there is no description, if there is no price, or if there is no file URL, we want to go ahead and return, because you don't want to let them list something if it doesn't have those values available. We then want to go ahead and stringify the name, the description, and the image in a variable called data. And then we can basically save this value to IPFS using the same thing that we did earlier, where we kind of called client.add. And here we're going to say const added is equal to await client.add. And then we're going to go ahead and set a value called URL. And this is going to be now the IPFS path that includes the name, the description, and the image URL to a separate IPFS location. So we have two things happening now with IPFS. And then with that URL, we can set this URL as the token URL by calling this function called create sale that we can go ahead and create now. And you could kind of like think of create sale as kind of like listing an item for sale, but we're also creating the NFT in the same function. So we have two things really going on. So very similarly to how we worked with Web3 modal before, we call a reference to Web3 modal.connect. We then get the provider, we then get the signer, the same thing we did before. So now we have the signer. The thing that we're going to do here, again, we're going to be interacting with two contracts. The first thing we want to do is interact with the NFT contract. So we create a reference to the contract. We say ethers.contract, passing in the NFT address and the ABI as well as the signer. And what we want to now do is we want to call create token. And this is going to go ahead and create that token. And now we want to go ahead and wait for that transaction to succeed. And what we now need to do is we want to get the token ID returned from that transaction. And this is a little complex because you can't just wait for that return value and use it as is. You have to do some modification based on the return values. So there's an events array that we get back, and we can say we want to go ahead and get a reference to that events array by calling transaction.events and getting the 0th item. And then within that array, there's another array called args, and we want the second value out of those arguments. Or I'm sorry, this will be the third value because it's 0 index. So 0, 1, 2. So this is the third item. And then that value needs to be turned into a number because right now it's a big number and we want to turn that into a number. So we can call it that number. So now we have a reference to the token ID. The next thing we want to do is we want to get a reference to the price that we want to sell this item for. And the way that we do that is we call ethers.utils.parseUnits, passing in the form input.price and then ether. And this is basically going to turn that one basic number to like that very large number with all of the zeros, essentially kind of like turning it into way you could think of. All right, we want to now move the reference of the contract away from being the NFT to now we want to create a reference to the NFT market address and NFT market contract. So we can now use that same reference to the signer, and we're now going to be changing the contract variable to now be referring to the NFT market contract. We want to get the listing price. So we call await contract.listing price. We turn that listing price into a string because we want to be able to basically send the value within this transaction to the contract to make sure we're paying for that listing fee. We wait for the contract.createMarket item to succeed, and here we're passing in all the values that we need. We're passing in the NFT address, which is the the contract address for the NFT. We're passing in the token ID and the price. So here I'm kind of like putting this item for sale. I'm setting the token ID as well as the price, and then the value that's going to be extracted from my wallet is the listing price. And then we kind of wait for this transaction to succeed. And then now we want to go ahead and reroute the user to another page. So we're going to say router.push, and we're going to send them back to the main page where we're going to then refetch these NFTs and we're going to render them. All right, so now we can go ahead and return our UI. Here we basically want to have a form for the user to be able to interact with our, the functions that we just wrote there. So I'm going to wrap our form in a couple of divs. The first div is going to be a flexbox container, justify center. And then this one's going to basically set the width as like 1/2. So, some very, very generic width. It's probably not perfect on a responsive site, but it's kind of a good start. The next thing we want to do is we want to have inputs for the asset name or the NFT name. And here we're calling, the placeholder of asset name, and we're going to call update form input. And whenever someone types into this, we're going to basically be updating, that local form input variable. And update form input will basically return all of the existing form input, and it will only change the name. So asset name, we're setting the name, and then we're setting the value to be event.target.value. For the description, we're not just using a basic input. We're going to use a text area to give the user a little bit more room to type. But very similar thing happening on the on-change handler. We're setting the description, and just like here, we set the name. So this sets the name, this sets the description, and you can guess what the next one does. It sets the price. So here we're setting the asset price in ETH, but in our case, maybe we could say Matic. And this updates the price. And then finally, we want to go ahead and show the file input. And instead of using input with an on-change handler, like with the event being passed and doing that, we're just going to call this on-change handler that we defined earlier, and we set the type of input to be file. We want to have a button that allows the user to create this digital asset. So we have this button. We're adding some, class name to it to give it a little bit of styling. I'm going to go ahead and format this a little better. So we have a button with a font, we have a margin, a background, things like that. And then the inputs that we're working with have, their own basic class names as well, margin, border, and padding, and things like that. Now, the last thing we might want to do is kind of like show a preview of the file. So to do that, I might go ahead and say if there is a file URL, meaning that like they've uploaded a file, we want to show an image with the image source being the file URL. So that is this component. We've gone ahead and created that. We should go ahead and save this and maybe test it out. So if I go ahead and refresh and we go to sell digital asset, if everything works as intended, we should now see a function. But I think it looks like I'm referencing the wrong function. So I need to reference the create item function. Here. So let's try that again. All right, there we go. So our app is loading. I have now, the ability to navigate between home and sell digital asset. So let's go ahead and test out selling a digital asset. And we still have to go ahead and fill out these other two components. But for now, I'm going to go ahead and open MetaMask, and I can switch now to my local host. So localhost 8545. And I need to now have a wallet that has some data, or not data, some ETH in it. So I can do that by opening up my node where I ran, my local node, and I can go ahead and import one of these accounts. And when you create the node, it gives you the account ID or the account address as well as a private key. So I can just like copy this private key, and for testing purposes, I can go ahead and like say I want to import an account, private key, boom. We now have 10,000 ETH, and we can maybe test this thing out. So I'm going to go ahead and try that out. So I'm going to say my first NFT. We'll set our price and upload a file. So here we should be able to go ahead and choose the wallet that we want to work with. I'm going to use the one with 10,000 ETH. Oh, it looks like we have an error. It looks like when we called create token, we're not actually passing in that URL. So what we want to do is make sure that when we call create sale, we're getting that URL here. So let's go ahead and save that and try one more time. All right, now we're being prompted to go ahead and, pay some gas to go ahead and create the token. We'll go ahead and confirm that. And now we're being prompted again to actually put the item for sale. So we're paying that listing fee of 0.02 as well as some gas. So the total, including the gas, is like 0.026. So we'll click confirm. And there we go. We're now viewing the items for sale. So if we go to sell digital asset and navigate back to home, we see that. And we also see a link to go ahead and buy it. So that's great. If we go to my digital asset or creator dashboard, though, we're still getting 404. So we have not yet created those. So let's go ahead and continue on and creating those. So to do that, I'll go ahead and open my text editor. And the next file we want to create is for our own assets. So we have that link for my assets. So let's go ahead and create a page for that called my-assets.js. And here we can go ahead and start writing our code. This is going to be kind of similar, repetitiveness from some of the stuff we've done before. We're importing ethers, we're importing use effect and use state. We're importing Axios, we're importing Web3 modal. We're also importing, our references to our address is. We're importing a reference to our APIs for NFT as well as for market. And again, I want to update this to make sure we're getting the market.sol/market.json. We have our main component name called myAssets. And this is the function, or this is the component where we're calling the function where we're only returning the items that we have purchased ourselves. So these are going to be the items that we've bought. So I'm going to run through this a little more quickly than some of the other stuff, just because we've covered a lot of this already. So we'll have a couple of pieces of loading state. We're going to have, we're going to have a couple of pieces of local state. One is going to be for the array of NFTs. One is going to be showing the loading state of loaded or not loaded. We're going to then call this function, or we're going to have a function called load NFTs that we can call and use effect. And we'll say load NFTs. And the load NFTs function is going to basically be very similar to what we've done before. In this case, we're still using Web3 modal. I actually don't need to pass in any of these arguments here, I don't think. So we're using Web3 modal, and instead of like when we called to query the array in the main index where we were just calling using the JSON RPC provider, in this case we actually do need to provide a signer because we need to know who the message.sender is. So we're kind of combining a little bit of functionality from a couple of other components that we worked with. So we're using the signer to get a reference to the market contract because we actually need to we need to know the message.sender, meaning that if we navigate to this page and we haven't already authenticated with a wallet, we will automatically see that wallet modal pop up. We then fetch the tokens. We then fetch the market items, calling market contract.fetch my NFTs. We map over them. We do some of that similar functionality where we get the token URI, we get the token metadata, we update that here, and then we set the NFTs and we set the loading state. We check to see next if the loading state is loaded and if there are no NFTs. We basically give the user some feedback saying, hey, you have not purchased anything, so there are no NFTs. And then finally, we'll go ahead and return our UI. And here we're going to have similar layout to what we did in the past, where we kind of have a couple of divs for layout. And within this center div is where we call NFTs.map. All right, so we're kind of like mapping over all of the NFTs, and here we want to go ahead and return something. And in our case, we're going to be returning just, a view of the NFT itself with the NFT image as well as the NFT price that we paid. So fairly simple UI compared to the UI where we're actually giving a button to like purchase an NFT. So now if we go back to our app and we refresh, it looks like I maybe misnamed something. Yep, this needs to be lowercase. So let me try that again. So it looks like everything's working now. So we have a list of the assets that we've purchased, but we haven't purchased any. So it says no assets owned, and then home. Now the last thing we'll create is the creator dashboard. So if we click there, it should be 404. So let's go ahead and create a file called creator-dashboard and pages. And in creator dashboard, this is where we're going to go ahead and do similar functionality like we did in my assets. But in this case, we're going to be creating two views, or we're going to have two different arrays of data. So we'll go ahead and do our imports, same as before, ethers, use effect and use state, as well as Axios. We're importing our addresses. We're importing our contract ABIs, market and NFT, same stuff we've been doing. Of course, I want to go ahead and update that. We want to have a component called creator dashboard. And instead of having just a single array of NFTs, we're going to have two arrays. One is going to be arrays that we've created. NFTs that we've created. It's going to show everything. And then we also have a separate array just for the items we've sold. So we can kind of have like two different views. Similarly to before, we have our loading state. We have our set loading state. We have our load NFTs function. Very similar to our other load NFTs function. The main difference is that not only are we going to have our, let me go ahead and delete that. Actually, I don't think we need that. So the main difference is that right now we have our items array that we've, the same items array we've been working with, where we kind of like map over the items. We also want to create a separate items array where we map, or we filter through the items array here, and we also attach like a check to see if the item is sold. So we have now two arrays. We have the array with all of the items that we've created and only for the sold items. And then this way we can go ahead and set the sold items as well as just all of the items themselves. So now we can kind of basically have two separate views. We first want to show a list of the items that we've created, period, like all of the items. And then we also want to have a view of only the items that have sold. All right, so to do that, I think the first thing we'll do is just map over all of the NFTs. So kind of going through this faster now because it's very similar to what we've done before, where we have some layout, where we're saying nfts.map, and we're kind of like only, we're returning all of the items that we've created, period. We also want to have a separate view here. So we have this view here, or this array here, and then we're having another one here. Now this is going to be a little bit different because we basically want to see if we have any items in this array, period. And if there are, then we want to go ahead and map over them. Or, in reality, it's just literally an array. But I think the main difference is that we can show and toggle a title if there are items that have been sold by doing some logic like this, where we say Boolean sold.length, meaning like if this is true, we can actually go ahead and return a div, and this will hold all of the UI we want to kind of show in this case. All right, so here we might go ahead and show like a title or an H2 or something, where we're basically saying, these are the items you've sold. We're going to now have a grid similar to what we've written before. And now we can basically map over that item, that array of items. So we can say sold.map, and this is mapping over those items. So I think with that code being written, I think that's about it. So we can go ahead and maybe test this out. So I'm going to go back to Chrome, and now we should be able to navigate to Creator Dashboard and see that our items have created have been there or are there. So now we see that all of our routes are working. We have My Digital Assets, Creator Dashboard, and Home. And I think the next thing we might want to do would be testing out the functionality. So we want to test out, does this actually work if we, make a sale, and then does that value get transferred between different owners? So to do that, we might go ahead and go back into, our Hardhat and create another account using one of these private keys, and then create a transaction. So I'll go ahead and say import account, and now have account 4. So I will go ahead and switch to account 4, and it looks like now I'm on account 4. So what I want to do is try that. So I don't know, I think this should work. Let's go ahead and click buy, and go ahead and click confirm. And if we go to MetaMask, it looks like, the amount of Ether has been taken out of my wallet. And if I go to creator, I'm sorry, if I go to my digital assets, yep, looks like I paid 1,000 for this. And it looks like that the seller now has 1,999, which is basically, you know, 11,000 minus the gas costs. So yes, that's awesome. We've gotten there. We're getting there, I would say. The next thing I might want to do would be to go ahead and deploy this to the Mumbai testnet. So to do that, I need some Ether. So to some test Matic actually. So I can go to the Mumbai testnet faucet, and I can go ahead and request some test Matic. But before I can actually see that, I need to connect to that Matic network. So earlier we had opened up the Polygon documentation. So again, if I go to developer, proof of stake chain, click on network details, network, I should be able to see the Mumbai testnet configuration. So basically what I want to do is I want to import this into my wallet. So here I can go to custom RPC right here. I'll call this Mumbai. The RPC URL, chain ID is 80001. Symbol, we'll go ahead and save that. And now we are officially connected to the Mumbai test network. And it looks like I've used this account earlier at some point, I would say, to request some Matic. But let's say I had it. I could just copy my address here and go to this local or this testnet faucet, click submit, click confirm. And it looks like the transaction succeeded. So at some point I will have another 0.1 Matic sent to this account, which will allow me now to go ahead and deploy from this account. So to deploy from this account, the main difference that we need to do is, like, we've already set everything up in our, let's see here, in our Hardhat config, where we have our network stuff set up. The main thing I need to do is specify Mumbai when I deploy. So the way that we can do that is we can go to where we deployed last time, where we ran npx hardhat deploy. This time, instead of saying network localhost, we can say network Mumbai. Now I need to make sure that the address that I'm referencing with my private key actually has some testnet Matic. So the way I can do that is just go ahead and send some Matic to that address. So I think that was account number 2. And here I can go ahead and copy this address, and we'll go back to the faucet. I'll enter this new address here, go ahead and send to that address. Try it again. Sometimes this thing errors out. All right, so we've sent to this address. Now all we do is wait. So in a moment, we should have our Matic in this wallet, and then we should be able to go ahead and test this out. So it looks like it's already there. So 0.1 Matic. So I have that, or was it to account 1 actually? Let me send, I think that was account 1. So let me go ahead and actually send it to account 1. All right, so we sent tokens to both accounts. So theoretically we could use either one, but let me go ahead and wait for this to come through. All right, there we go. We see we have our 0.1 Matic. So now we should be able to go ahead and deploy this contract from this. So to do that, I'm going to go back to my terminal, and I'm going to go ahead and run this script and see what happens. Now this deployment is probably going to take a little longer than deploying to your local node, of course, so we'll give it a couple of seconds. All right, looks like we are getting something. Oh, it says insufficient funds for this transaction call. So I guess because I'm deploying, 2 contracts, it's going to cost more than that. So what I can basically do is just, I'm going to go to this account where I have a bunch of Matic, And I'm going to send like everything, I would say. And I'll jump back to this account and wait for that to come through. And there we go. We have our 0.3 Matic, and we're going to run this script one more time. All right, there we go. We've officially deployed to the Polygon / Matic network. So let's now test out our front-end application. Now, the great thing is that we don't really need to change anything, or I wouldn't say anything. We don't have to change a whole lot to make it work. The one thing we want to keep in mind is that we've now switched between networks. So, you know, if we've connected or anything like that to any of these accounts, we need to kind of like go ahead and consider disconnecting our connection. But you're going to notice probably that when we load this, that this is going to error out or something like that. The main reason, well, we need to do two things to make this work actually. First of all, we need to set the JSON RPC address to the Mumbai testnet because we're no longer working with localhost. So the way I can do that is I can go ahead and copy this URL here, and the only place that we're using JSON RPC provider is in, I believe, in index.js. And here in load NFTs, we can now pass in the JSON RPC provider there. And then the other thing we want to update is our config.js. Config.js, we need to update our contract addresses. So for the NFT market, I'll go ahead and copy that here. And for the NFT, I will copy that as well. And we'll go ahead and save that, and we'll go ahead back to our terminal. And just for the sake of it, maybe restart our dev server. And then we'll go ahead and open up our app on localhost 3000 and see what happens. All right, so it's looking like it's working. So let's go ahead and click through and try out different things. So it's now asking us to authenticate with MetaMask. So we can choose the account we want to work with. Maybe I'll choose one of these accounts that actually has some Matic. Now remember, there is a listing fee. So I went ahead and took the liberty of requesting even more. Testnet, Faucet, Matic. So now I have 0.39 Matic. You know, I'm kind of rich at this point. So let's go ahead and test this out by listing or selling a digital asset. So I'll go ahead and set the price to actually, I guess 1 is fine because we probably won't execute the sale because we don't have, a wallet with that much Matic. But we'll go ahead and list it. And now we'll go ahead and confirm this transaction. And we can now confirm the second transaction. And it looks like we have officially listed an NFT on Matic. So if I go to Creator Dashboard, I now see my item. If I go to Home, I see, I should see that item listed. Looks like I'm running into some type of network issue now. So let's see what's going on there. All right, so it looks like that, that RPC address I was using was not working. It was probably getting overloaded or whatever. So I went ahead and switched over to this custom RPC address. And come to think of it, I'm wondering, no, I don't think so. But I was just wondering if maybe because I actually transacted to that RPC, if I needed to now be on that RPC. Would make sense. I don't know the answer to that. But we've come a long way. I think the last thing we would want to do at this point would be to deploy to the main Matic network. Now, really the only difference to like what we would need to do at this point would be we would need some real Matic tokens, and we would need to be on the real Matic network. So let's go ahead and switch over to the real Matic network. We'll go ahead, like I mentioned, like before how we did the Mumbai network, we can go ahead and say we want to go to settings, we want to go to networks, we want to click add network, or we can go here, we can say custom RPC, either way. So the network name is going to be Matic mainnet. The RPC URL is that. The chain ID is 137. Currency symbol would be like Matic. And now we have the Matic network. And we're now connected to the Matic network. So all we would need to do would be to get some Matic tokens. And then we would be able to deploy from the Matic network. Now I don't have any Matic tokens that I can use right now. I do have some, but I don't feel like transferring them over and showing this would be like that much value add, because it's really exactly what we've been doing before. But for instance, the only thing we would do differently would be we would run this same script and we would say network mainnet, and this should fail because it should say something like, yeah, you don't have enough money to do this. So we'll go ahead and like maybe see what happens if we try this and we get that failure. Yeah, insufficient funds for transaction costs. So I think that actually wraps up this video. This has actually been one of the longest videos that I've ever done, and it's taken me a while to kind of like get through all this. And I'm hoping that through all of this you learned a lot. And really, if you do want to follow along with this, writing this actual code, I recommend going in and seeing the code examples that are linked in the description below and copying and pasting those if you don't want to kind of like write all of this by hand. So that is it. Thank you for checking out this video. We're wrapping it up now, and thank you for watching, and I will see you around for the next video.